Hello viewers, in today's session we are going to discuss another important and conceptual problem from functions, and here we are going to discuss this important problem where we are given two functions g of x and f of x, and g of x is given as x minus greatest integer of x plus 1, and f of x is defined like this, that is f of x is equal to minus 1 for all x less than 0, and f of x is equal to 0 for x is equal to 0, and f of x is equal to plus 1 for all x greater than 0. And here we are given the composition of f and g, that is f of g of x is equal to 2 alpha minus pi, where alpha belongs to the set of real numbers, and here we have to find the value of alpha, right? So let us see how we can find out the value of alpha using the concept of fractional part function, right? So let us start. So now the fractional part function is defined as fractional part function is defined as the difference of x and greatest integer of x, right? So the fractional part of x is defined as x minus greatest integer of x for all values of x belonging to the set of real numbers, right? And here we have x minus fractional part of x, so we can now write a g of x as fractional part of x plus 1, right? Now let us see the range of fractional part function. Now we know that the range of fractional part function is given by this interval, that is 0 to 1. So here 0 is included and 1 is excluded. So we can also write it like this: for all values of x belonging to R, fractional part of x lies in the interval that is 0 to 1. So here fractional part of x is greater than or equal to 0 but less than 1. So now let us add 1 throughout this inequality, because here we have fractional part of x plus 1, right? So adding 1 throughout, we have here 0 plus 1. So we can now write here 0 plus 1, and here we have fractional part of x plus 1, and here we have 1 plus 1. So 0 plus 1 is 1, and for fractional part of x plus 1, we can now write the function g of x. So here we have g of x, and here we have 1 plus 1, 2. So from this inequality, we can easily conclude that the function g of x, it belongs to this interval, that is 1 to 2. So here 1 is included, right? And from this interval, we can easily conclude that g of x should be a positive number. So this is an important point while solving this problem, right? So g of x must be positive, because g of x, it lies in the interval that is the positive numbers 1 and 2, where 1 is included. So now let us come to the composition of f and g. So here we are given f of g of x is equal to 2 alpha minus pi, right? Now see here we have f of g of x, that is the input is g of x, right? And we have just shown that g of x is a positive quantity, right? So we have f of some positive number here, because g of x is positive, and here we have a 2 alpha minus pi. Now f of some positive number is equal to 1, because here f of x is defined as f of x is equal to plus 1 for all x greater than 0. So it means this x is positive. So f of x is equal to plus 1 whenever this x is positive, right? So f of positive number should be equal to 1. So whatever be the value of g of x, where g of x belongs to this interval 1 to 2, where 1 is included, so f of some positive number should be equal to 1. So here we have 1, because f of positive number is equal to 1. So we have now this equation, that is a 2 alpha minus pi is equal to 1, and from here we can easily find out the value of alpha. So we have 2 alpha is equal to 1 plus pi. So we have alpha is equal to 1 plus pi over 2. So this is the required value of alpha when g of x and f of x are defined in this way, and we are given the composition of f and g as equal to 2 alpha minus pi. And here it is important to note that g of x cannot be equal to 0 for any value of x belonging to R, because g of x belongs to this interval, that is 1 comma 2. So here we cannot have g of x is equal to 0. So g of x is always going to be positive, and f of some positive number should be equal to 1, because f of x is defined as plus 1 for all positive x, that is x greater than 0.